This is a question on series and summation notation. So we are given that this one r equals to 1 for this is a given formula, and this is equals to 7 over 6 minus 4m plus 14 over m plus 3 m plus 4. So students must be very careful about handwriting, right? The minus should never join with this in case it is left out in the later working. We forgot that there's a minus sign there. So then we are asked to find what is this in terms of n. So I always encourage students to list out the terms, to see clearly what this really means. So this one, if you substitute the r equals to 3, the first term should be equals to 3 plus 2. So for this is the r equals to 3, and then we will have r equals to 4. So we will have 4 over 6, 4, then 4 plus 2, 6, and so on and so forth. And what is our last term? Our last term, when you substitute in, it should look like 4, 2m plus 2, and 2m plus 2 plus 2, so 2m plus 4. So this will be our terms. And then we are supposed to express it in this form. So we try to change this notation to something similar to this before we can apply this formula. So now, if we change n equals to 3, then the formula will just change all the n, replace with 3. This is how this works, right? When this is n, any n here should change, all this n should change. So what if this one we change it to 2m plus 2? Then all this formula would change to 2m plus 2, 2m plus 2, 2m plus 2. Okay? So, but now we are not going to do that yet. Right, we must find out what is this this one equals to. So we'll have this. Now we change the bottom part first. This it's just my choice. Okay, so when I change it to r equals to 1. When I change it to r equals to 1, what would all this be? Right, I must still make sure that the formula I give here will describe this. So 4 is always constant throughout, so yes. Now when r equals to 1, then this term must be r plus 2. I realize every term is increased by 1, so r plus 2 happens to be, looks like this. And if this r, when r equals to 1, this one must be r plus 4. So do you see that this happens that to be the same as this? That means we can apply this formula. And now what should be on top? On top is the ending term. So we must make sure when you substitute something, it should give us the ending term. So if I substitute 2n into r, it should give me here, this will become 2n, and 2n will give me 2n plus 4, so that will be my last term. So that means this series is equals to this series, which is exactly equals to this series. If you don't believe, you just substitute 1 and you get 3, you get 5 here. And when you substitute 2, you get 4, you get 6 here. And when you substitute the last term 2n, you get 2n plus 2 and 2n plus 4 here. And let's count the number of terms. The number of terms must also be the same. So the number of terms here is 2n plus 2 minus 3 plus 1. And what does it mean? This means that this is 2n, 2 plus 1, 3, 3 minus 3 is 0. So there are 2n terms over here. Number of terms in this series is 2n. And so the same for this. 2n minus 1 plus 1 will give the number of terms in this series. Alright, it's always the top minus the bottom and add 1. That will give the number of terms in this series, because the number of terms in this series always go 1 by 1 by 1. So the first term we substitute is 1, next term we substitute is 2. We count until we reach 2n. So the way to get the number of terms in the series is always the same, top minus bottom and add 1. Okay, so since these two are exactly the same, now I apply the formula here. So notice everything is the same, except this n is changed to 2n. So the formula here, all the n must change to 2n. So I'll write 7 over 6 minus 4 times 2n, which is 8n plus 14, and here we will have 2n plus 3 and 2n plus 4. So our job is done, right? That's it.